Hi, welcome to another mathematics lesson. My name is Kingsley Linus. In today's lesson, we'll be looking at the topic Data Presentation, Part 1. By the end of this lesson, you should be able to define data presentation. Secondly, you should be able to present data in an ordered form. And lastly, you should be able to construct frequency tables from any given data and also present data using frequency distribution tables. In our previous lessons on data collection and the need for statistics, we learned about data. Data can be said to be raw, unprocessed, unorganized facts. Data most times is usually in forms of figures or numbers. For example, the age of people in a class. We can also get data from readings on instruments. Now, when we collect all this data, it is usually for a specific purpose. This data can be analyzed, organized, edited, modified, and so on, to a point where it becomes so useful and easy to understand. At this point, it can be referred to as information. So going on, statistics has to do with data interpretation and presentation. But our focus for this lesson is data presentation. Let's go further to learn about what data presentation is. Simply put, data presentation is the creative use of texts, charts, graphs, and tables to present data in a manner that it becomes easily understandable. Let's go further to learn about the importance of data presentation. Before we present data, data analysis must have taken place. Let's find out some of the importance of data presentation. First, data presentation helps people in understanding the results of surveys conducted. It also makes use of already existing studies to obtain new results. And lastly, for this lesson, it helps to validate existing research or to add and expand the current research. Now, there are two major categories of presenting data. We have the graphical method and the rank order method. In the graphical method, we make use of graphs, charts, and so on. While in the rank order lists, data is presented in such a manner where it takes either an ascending order or a descending order. It is very important for you to note that the rank order lists can also be called array. It is important for you to note that the term ranking describes the relationship between two objects in a group such that one is higher than, or lower than, or the same as the other. This is simply what ranking is about. Let's look at some examples to get better understanding about rank order lists. Our example says, arrange the following scores in ascending order of magnitude. You can see the list of scores. B, which is the highest score? C, which is the lowest score? D, how many scores are above 60%? Now, the first thing to do is to arrange the scores from the lowest to the highest, because the instruction says in ascending order of magnitude. So we have 10%, 16%, 20%, 35%, 40%, 50%, 60%, 70%, 80%. Now, having done this arrangement, it is easier for us to get the answers to the rest questions. Which is the highest score? Obviously, you can see that the highest score is 80%. The next question says, which is the lowest score? Obviously, from our arrangement, we can see our lowest score as 10%. So, the answer to question C is 10%. And lastly, we have how many scores are above 60. Here is our 60 score. So we take the scores that are above 60, and that is two scores, 70% and 80%. We have another example that says customized jackets were made for 30 pupils in a class. Their sizes are as follows. We have the list of their sizes. Question A says arrange the sizes in rank order. Carefully, we have arranged these scores. Now, question B says if you were the merchant to deliver these goods, which two jacket sizes would you prefer to order? Now, looking at our array, you realize that we have size 7 and size 9 appearing more frequently. So it will be easier for you as a merchant to sell out jackets with these sizes. So size 7 and 9 is the answer to that question. And lastly, we have which two sizes would you not like to order? So you can see size 10 is just for only 2 people, and we have very few people who use size 6. So the answer to that question is size 6 and 10. Now let's look at another important part of this lesson, the frequency distribution table. Usually, a frequency distribution table has 3 components: an array, the tally, we usually use strokes to represent the tally, and then the frequency. Let's look at a table that shows how these arrangements are done. This is a random table that shows a list of scores in an array. You can see from 1 to 6, and then we have the tally, that is, we have strokes that shows us the number of times we recorded these scores. And after the tally, we can now bring out the frequency of these scores in numbers. So this is what a typical frequency distribution table looks like. Let's look at some examples to better understand the frequency distribution table. Example 1. BrainFriend Academy intends to employ 30 new educators. The following scores are the marks in percentage for a test administered to the new employees. You can see the scores as recorded from the test administered to these new employees. Now we are expected to represent these data in a frequency distribution table. Now, the first thing to do is to write out our array. Now, from the data, we must check out. Now, we must look at the data to find out what our lowest score and our highest score are. From observation, our lowest score is 40 and the highest score is 100. So we can go ahead to make an array of the scores. We have 40, we have 50 represented, so the next is 50. We also have a 60, so we have 60. We also have 70, 80, 90, and 100. Now, we must go through the data one after the other to represent each score with a tally mark. Now, to do this, we'll find it much easier and organized to go row by row. First, we have 80. So we make a stroke for 80. We have 60. We have a stroke for 60. Another 60, 90, 100, 100, 90, 100, 80, 90, 70, 40, 60, 90, 70, 100, 80, 90. While representing our data using the tally system, When we have a fifth observation of a particular item, we cross the 4 strokes we already made. This would help us to easily calculate our frequency in a situation where we have so much data to record. I believe that is clear enough. Now we continue 80 and another 80. So we cross. We have 70, 70, 90, 80, 100. We cross. 100, a stroke. 50, 1, 60, 90, and another 90. So we can now have our frequency. We have 1, 1, 4, 4, 6, 8, and 6. Now the total of this, we have 1 plus 1, that gives us 2, plus 4, that gives us 6, plus another 4, we have 10, plus 6, 16, plus 8, 24, and then plus 6, that gives us 30. Ordinarily, this tells us that we have accurately represented the data given. So, you see, from this table, we can answer quite a number of questions. Like, for example, you can tell that we have at least 6 candidates who did very well in these tests. Example 2, 30 kids in a group were to be given Christmas gifts according to their ages. Find their ages below. You can see their ages here. Now, we are asked to represent the above information in the frequency distribution table. We already have our array of the age. The next thing to do is to go ahead and represent our data in the tally system. As usual, from row to row, we have 8, a stroke, 6, 7, 9, 10, 10, 7, 8, 5, 6, 9, 11, 8, 9, 7, 5, 6, 11, 8, 9, 6, 9, 7, 10, 8, 9, 9, 7, 10, and 5. So we can have our frequency. We have 3, 4, 5, 5, 7, 4, and 2. And we add them. 3 plus 4 gives us 7, plus 5 gives us 17, plus 7 gives us 24, plus 4, 28, and plus 2, we have 30. Okay? So, we are expected to find out the highest occurring age. We can tell that from our frequency. The highest number on our frequency is 7. So, the highest occurring age is age 9. So, our answer here is age 9. And then the last question says, what percentage of the kids are above 7 years of age? So, from 8 years and above, we will put all of that together. That means 5 plus 7 plus 4 plus 2. And that gives us 18. So 18 out of 30 multiplied by 100, because we are expected to find out the percentage. Now 0 cancels 0. 3 into 3, 1. 3 into 18 gives us 6. So we have 6 times 10. That gives us 60%. So 60% of the kids are above 7 years of age. Having seen these examples, it's time to do it yourself. Pause the video and try out the exercises. I'm sure you are done. Exercise 1 says, a mental sum test was graded from A to E. The grades of 20 students in the test are as follows. We have the list of their grades. Question A says, list the grades from the highest to the lowest. We have A, 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 B, 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 C, C, D, 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 E, E, and E. Question B says, which grade was achieved by the highest number of students? Now, from our array, you discover that A has the highest number of appearance. So, the answer to that question is A grade. The A grade appears most frequent. Question C, how many students got grade D and above? When we count all the grades from D up to A, you discover that we would have 17 students. And question D says, if grade E is considered failure, how many students failed? You can see we have 3 grade E's, so 3 students failed. Exercise 2 says, copy and complete the table. Now the array has been done, the tally has been done. You need to copy out this table and then complete the frequency and answer the questions that follow. Now for our frequency, we have 4, 7, and 3. And that amounts to 14 total. The table is a compilation of the shoe sizes of pupils in primary 5A. How many pupils are in 5A? Of course, from our total, you can see that there are 14 pupils. Next, what size of shoe appears most? From our frequency, we have the highest frequency as 7. So size 9 is the answer to that question. Size 9. How many pupils wear size 9 and less? We have 7 and 4. That gives us the number of pupils that wear size 9 and less. So 4 plus 7 gives us 11. So we have 11 pupils. If these were your answers, you are correct. With those exercises, we have come to the end of this lesson. But before you go, let's look at a summary of all we've learned so far. First, we learned that data is raw fact or unprocessed records. Secondly, we learned that data presentation involves the creative use of texts and different pictorial or graphical techniques to visually convey information in a way that is easily understood. Thirdly, we learned that data presentation is categorized into rank order lists and graphical representation. Going further, we learned that the rank order of data presentation puts data in ascending or descending order of magnitude. And lastly, for this lesson, we learned that a frequency distribution table shows how often a particular value occurs in a set of data. I am sure you know it's test time. Let's see our test questions. Question 1. The act of arranging and expressing raw facts or unprocessed records in a form that it becomes simple and easily understood is A. Data processing. B. Decoration. C. Data presentation. D. Representation. The correct answer is option C, data presentation. Question 2. A table that shows how often certain values, objects, or events occur is called a dash table. A. Accuracy table. B. Ranking table. C. Presenting table. Or option D. Frequency table. The correct answer is option D, frequency table. I believe you've learned something new about data presentation. Till we meet again in the part 2 of this lesson. Bye-bye.